morning, everyone. So, welcome to my YouTube channel, Masatra. So, today we are going to see new topic. Uh, we will call it Jacobian. Okay, call it Jacobian. So, let U1, U2, UN. Okay, be the functions of independent variables x1, x2, xn. It means what? U1 is equal to U1, x1, x2, up to xn. U2 is equal to U2, x1, x2, xn, and so on. Un is equal to un, x1, x2, up to xn. Okay. Then the determinant, then the determinant, then the determinant. We will denote it by u1, u2, un upon x1, x2, xn. That is nothing but determinant del u1 x1 del u2 del u1 del x2 and so on del u1 del xn del u2 del x1 del u2 del x2 del u2 del xn and so on del un x1 del un x2 del un xn. Okay, then this determinant is called Jacobian. Jacobian of u1, u2 up to un with respect to x1, x2 up to xn. Okay, the Jacobian of u1, u2, un with respect to x1, x2 up to xn is also denoted by del u1, u2, un upon del x1, x2, xn. Okay. So question first, if x is equal to r cos theta, y is equal to r sin theta, evaluate del xy upon del r theta. Okay. Solution. So x is equal to r cos theta, y is equal to r sin theta. So what we have, del x upon del r is equal to cos theta, del x upon del theta is equal to minus r sin theta, and del y upon del r is equal to sin theta, and del y upon del theta is equal to r cos theta. Therefore, what is Jacobian? Jacobian x, y, r theta, that is equal to del x, y, del r theta, nothing but del x upon del r, del x upon del theta, del y upon del r, del y upon del theta. So this implies del x, y upon del r theta is equal to, what is this? Del r upon del, that is cos theta, cos theta minus r sin theta. And what is this? This is sin theta r cos theta. You solve this determinant. This determinant is nothing but r cos square theta plus r sin square theta is equal to r cos square theta plus sin square theta. This is 1. So this implies del xy upon del r theta is equal to r. See, we got its value. Now, now note, now x is equal to r cos theta and y is equal to r sin theta is given. Okay. Now, now after solving this, what will get? X square plus y square is equal to r square. cos squared theta plus sin squared theta, that is r square. Okay, this implies r square is x square plus y square. And if we divide, tan theta will be equal to sin theta upon tan theta is equal to y upon x. Okay, so we have r square is equal to x square plus y square, and theta is equal to tan inverse y upon x. Now, what is what is del r theta del x del y? Because here r is function of xy, theta is also function of xy. We can also ask question, what is this? Now, r square is x square plus y square. So this will imply del r upon del x is equal to 2. Differentiating both the side with respect to x, that is 2x. 2 will be cancelled out. This will be del r upon del x is equal to x upon r. Okay. Similarly, 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 what is del y upon del r? That is also y upon r. Now, what is now theta is equal to tan inverse y upon x. So what is del theta upon del x? So this will be 1 upon 1 plus y square upon x square. Now partial derivative with respect to x of y upon x square. This will be y upon x square. So this is nothing but del theta upon del x, that is minus y upon x square plus y square. X square y square is r. This value is r. Okay. This is r square. Sorry. Okay. Now what is and del theta upon del y? What is this? This is nothing but 1 plus y square upon x square with respect to y. So this is 1 upon x. So this is x upon x square plus y square, that is x upon r square. Okay. Now next, what is del r theta upon del x del y? What is that? Del r upon del x, del r upon del theta upon del x, del theta upon del y. Okay. So what is the value of del r upon del x? X upon r. x upon r. What is del r? X upon y upon r, sorry, y upon r. And what is del theta upon del x? Minus y upon r square. This is x upon r square. So what we got? X square r cube plus y square r cube. Now what is this? X square plus y square upon r cube. So this is actually above thing is r square. This is r cube. So 1 r is should be got 1 upon r. So this implies del r theta del x del y is equal to 1 upon r. Note that del xy del r theta then del r theta del x del y. This was r. Now this is r only. So they will go to 1. So such things happens. We will show it later on as a property. Okay. Now question 2. If y1 is equal to x2 x3 upon x1, y2 is equal to x3 x1 upon x2 and y3 is equal to x1 x2 x3, so that the Jacobian of y1 y2 y3 with respect to x1 x2 x3 is 4. Solution. So what is del y1 upon del x1? First we should write it. So what is y1 is equal to x2 x3 x1. So del y1 upon del x1, what is that? Minus x2 x3 upon x1 square. Del y1 del x2 is equal to x3 upon x1. Del y1 del x3 is equal to x2 upon x1. Now y2 is what? x3 x1 x2. So del y2 upon del x1 x3 upon x2 del y2 upon del x2 is equal to minus x3 x1 upon x2 square. Del y2 upon del x3 is equal to x1, x2. And what is y3? x1, x2, x3. Del y3 upon del x1, x2 upon x3. Del y3 upon del x2, x1 upon x3. And del y3 upon del x3. What is this? Minus x1, x2, x3 plus square. Now let's calculate Jacobian. So what is del y1, y2, y3 upon del x1, x2, x3? What is that? That is nothing but del y1 upon del x1, del y1 upon del x2, del y1 upon del x3, del y2 upon del x1, del y2 upon del x2, del y2 upon del x3, del y3 upon del x1, del y3 upon del x2, del y3 upon del x3. So what is this? Minus x2, x3, x1 का square, x3, x1, x2, x1, x3, x2 minus x3, x1, x2 का square, and this is x1, x2, and this is x2, x3, x1, x3 minus x1, x2 upon x3 square. Okay, so we are taking common 1 upon x1 square, x2 square, x3 square. So what is this then? Minus x2, x3. Okay, x3, x1, and x1, x2, x3, x2 minus x3, x1, x1, x2, x2, x3, x1, x3, x1, x2. Okay, so now what you will do? You take common. So in first column we can take x2, x3 common. In second column we can take x3, x1. In third column we can take x1, x2. So it will be finally x1 square, x2 square, x3 square, and already it was there in denominator because the numerator is common. In first column we have taken common x2, x3. In second column we have taken x1, x3. And third column we have taken x1, x2. So what is this? Minus 1, 1, 1. 1 minus 1, 1, 1, 1 minus 1. Now, what is the value of this determinant? So, this is actually 1. This is actually 1. So, what is this determinant? So, determinant's value we will calculate. What is this? So, what is this value? I will add this column here. I will add second column in first one. It means C1 is nothing but C1 plus C2. Okay. And C3 is equal to C3 plus C1. So what I will get? 0, 0, 2. 1 minus 1, 1. And this is, and C3 goes to C3, C2. Okay. So this is 2, this is 0, and this is also 0. Now expand this, determinant along with the first column. So this is 2, this is 10, this is 0, this is 0, this is 2 into this multiplication with this 0, and this minus this multiplication with minus 2, that is 2 into 2 is equal to 4. So this has been proved that Jacobian is actually 4. Okay, Jacobian is 4. Now question 3, if x is equal to r sine theta cos phi, y is equal to r sine theta sine phi, and z is equal to r cos theta, so that del x y z upon del r theta phi is equal to r square sine theta. So let's prove it. X is equal to what? R sine theta cos phi. So del x upon del r, what is this? Sine theta cos phi. What is del r upon del theta cos theta cos phi? Del x upon del phi is equal to minus r sine theta sine phi. Now y is equal to r sine theta sine phi. So what is this? Del y upon del r. This is sine theta sine phi. Okay. Now del y upon del theta is equal to r cos theta sine phi. Now del y upon del phi, what is that? R sine theta sine phi. Okay. Now, what is del z upon now z is and z is given r sine cos theta. So del z upon del r cos theta, del z upon del theta is equal to r minus r sine theta, and del z upon del phi, that is 0. Okay, because z is not function of phi. Now, what I will do now? Now I am to calculate. Therefore, del x, y, z, del r, theta, and phi is equal to del x upon del r, del y upon del r, del z upon del r, del x upon del theta, del y upon del theta, del z upon del theta, del z upon del phi, del z, sorry, del x, del y, del phi, del z, del phi. Okay, so what is del x upon del r sine theta cos phi, okay, and second r cos theta cos phi minus r sin theta sin phi, then sin theta sin phi, r cos theta sin phi, r sin theta cos phi. Okay, now cos theta minus r sin theta, and this is 0. Okay, now we will solve it. We will expand along third row. Or first we'll take r square. Uh, we'll take from From third column, we will take sine theta common and yeah, from third column we will take r sine theta common, and from second column we will take r common. Okay, so we have r square sine theta is equal to sine theta cos phi sine theta sine phi cos theta. So we have taken common r here. So cos theta cos phi, okay, cos theta sine phi, and this is sine theta minus sine theta. And from here we have taken r sine theta common. So minus sine phi, okay, cos phi 0. Okay, now solve it. So r square sine theta is outside. So expand with respect to third row. Okay. So first row we can expand sine theta cos phi sine theta cos phi, and we will get 0 here, 0 plus sine theta cos phi. Okay. Now then minus cos theta cos phi, 0 minus cos theta cos phi, minus, now next is minus sine phi, that is equal to minus sine square theta sine phi minus cos square theta sine phi. Okay, now go ahead. So what we have? We have r square sine theta. So this is sine square theta cos square phi cos square theta cos square phi, and this is sine square sine phi minus sine phi we can take common. So it will be sine square phi, okay, sine square theta plus cos square theta, okay, r square sine theta. From here we can take cos square phi common. Okay, so this is 1 here. So this is sine square phi. Okay. Now you see that this is also 1 because sine square theta cos square theta is 1. Here it is also 1. That is why we have written this. So cos square phi sine square phi. Again this is 1. So this is r square sine theta. Okay. So we have proved that this is r square sine theta. That was to prove. Okay. So Jacobian is r square sine theta. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.